So we've seen how we can use the area model to multiply numbers of several digits. Let's take a look again at what happened when we multiplied in that way. Let's see what happens when we multiply 29 times 52. 29 plus 52, that's 20 plus 9 times 50 plus 2. 20 times 50, we'll find 2 times 5 is 10, with 2 zeros on the end. 50 times 9, we'll find 5 times 9 is 45, with 1 zero on the end. 20 times 2, we'll find 2 times 2 is 4, with 1 zero on the end. And then 2 times 9 is 18, with no zeros on the end. So what we see here is when we multiply the digits in the ones place, we get a digit in the ones place, and then if the product is at least 10, we get a digit in the tens place. When we multiply tens times ones, or ones times tens, we get 1 trailing 0, and then a digit in the tens place. Here we got a digit in the tens place, and a digit in the hundreds place, because 5 times 9 was more than 10. Then when we multiply a tens place by a tens place, we get 2 trailing zeros, then a digit in the hundreds place, and a digit in the thousands place if it happens that the product is 10 or more. So when we add, notice, we ignore these trailing zeros. In the ones place, we have only one concern. In the tens place, we have these two digits that appeared in the ones place of single-digit products, and this digit that appeared in the tens place of this last single-digit product. We add those up. 5 plus 4 plus 1 is 10. In the hundreds place, we have a ones place from tens times tens, and then this digit that appeared in a tens place from tens times ones, and also this 1 that we carried from the previous place. 1 and 4 is 5. Then in the thousands place, we have only this digit that came from a tens times tens. Let me show you a way that we can organize this. I've just created a box with 2 rows and 2 columns because each of my numbers is a 2-digit number. I'm going to write my first factor across the top and my second factor down the side. And now the diagonals in my box here, these will correspond to the places that I saw in my sum. What am I going to do? In this little square, I'm going to write the result of 9 times 2, which, as we saw earlier, was 18. So this diagonal gives me my ones place. That's where the 8 is written. This diagonal over here will give me my tens place. The 1 is written there, and now when I multiply 9 times 5 and get 45, I write the 4 up here and the 5 down here. The 5 is in the diagonal that corresponds to the tens place. The 4 is in the diagonal that corresponds to the hundreds place. Same deal with 2 times 2. I get 4. Just so I know I haven't just forgotten about this box, I'm going to write that as 0, 4. Again, the 4 ends up in the tens place. The 0 ends up in the hundreds place. And finally, 5 times 2 was 10. I'll write the 1 up here, the 0 down here. This is still the hundreds place, and then this top diagonal corresponds to the thousands place. Now what did we do? We added up each place. We're going to add up down each diagonal. This first diagonal we just have an 8. In the next place we have a 5 and a 1 is 6 and 4 is 10. Write down the 0, carry the 1. 1 and 4 is 5. 1 by itself is 1. Now how do we read this? We read starting at the top left and coming down and around. Our product is 1,508, just like we found up here. Now this box gives us a perfectly good method for multiplying multi-digit numbers. However, it's a little bit messy. It requires that we draw this picture. We're going to see in the next video a method for multiplying multi-digit numbers that looks a little bit more like what we do for addition. But we're going to use this method to get from the area model to that model. And if you find that you often lose track of the place values in the standard algorithm, you are welcome to use this method for multiplication. So, let me show you another example and then I'll have you try one. Suppose we'd like to multiply 3,825 times 57. Now, because of the way notebook paper is set up, I always put my longer number along the top of the box. My longer number has 4 digits, so I need 4 columns. My shorter number has 2 digits, so I need 2 rows. I'm writing 3,825 across the top, 57 down the side. So I'm going to start down here in the ones place. 5 times 7 is 35. 2 times 7 is 14. 8 times 7 is 56. 3 times 7 is 21. 5 times 5 is 25. 2 times 5 is 10. 8 times 5 is 40. 3 times 5 is 15. All right. And now we add along the diagonals. The ones place is just 5. 5 plus 3 is 8. Plus 4 is 9, 10, 11, 12. So I carry the 1, write down the 2. 1 and 2 is 3, and 1 is 4, and 6 is 10. Write down the 0, carry the 1. 1 and 1 is 2, and 5 is 7, and 1 is 8. 4 and 5 is 9, and 2 is 11. Write down the 1, carry the 1. 1 and 1 is 2. So what's our answer then? The product is down and then around. 2, 1, 8, 0, 2, 5. 218,025. Now I'm going to give you one of these to try. Again, even if you've learned another method in the past, I'd like you to try this exercise using this method. Multiply 342 times 927. Pause the video and try it now. Okay, so I have 3 digits in each number. I need to draw my box with 3 columns. 1, 2, 3 columns, right? That requires 4 lines. And 3 rows. Now I fill in the diagonals, and I write my numbers 342, 927. And now I'm ready to multiply. 2 times 7 is 14. 4 times 7 is 28. 3 times 7 is 21. 2 times 2 is 4. And again, I'm going to write that as 0, 4, so I know I didn't just forget about this box. 4 times 2 is 8, 0, 8. 3 times 2 is 6, 0, 6. 2 times 9 is 18. 4 times 9 is 36. 3 times 9 is 27. And now that I've done all the multiplication, I add along the rows. I get just 4 here. 4 and 1 is 5, and 8 is 13. Write down the 3, carry the 1. 1 and 8 is 9, and 8 is 17, and 2 is 18, 19, and 1 is 20. Write down the 0, carry the 2. 2 and 1 is 3, and 6 is 9, and 0 is still 9, and 6 is 15, and 2 is 16, 17. 1 and 3 is 4, and 7 is 11. 1 and 2 is 3. So what's the product? Down and around. 317034. 317,034 is our product.